Welcome to Statistics, where we bring complexity to clarity. I am excited to have you join me for our 18th unit regression. Let's begin our regression journey by its brief introduction. The word regression was first used by Sir Francis Galton, and he introduced functional relationships between two variables. Many a times it is observed that change in one variable from a bivariate population causes change in the other variable, indicating a cause and effect relationship between the two variables. Here, the former variable is termed as independent variable, whereas the later as dependent variable. For example, quantity of fertilizer in the crop will have this type of cause and effect relationship, where quantity of fertilizer could be termed as independent variable and crop yield as dependent variable. This functional relationship between the independent and dependent variable is known as regression relationship. Regression is defined as a study of average relationship between two or more variables in terms of original units of the data. Regression can be linear or non-linear. Now let's see regression lines. In a scatter diagram, if the points are scattered around a line, then the relationship between two variables can be considered as linear. The resulting line is termed as regression line or line of best fit. For any pair of two variables that are related with each other linearly, a set of two regression lines could be observed, and they can be represented by two equations which are called regression equations. Let's see the regression lines and regression equations. Let x and y are the two variables. Then the two regression lines can be given by the two equations. That is, y is equal to a plus byx into x, or x is equal to a plus bxy into y. Let's check out for the first equation. Here in the plot we can see that the line represents y is equal to a plus byx into x. Here a is the intercept and byx is the slope. This we can compare with the straight line equation. It is similar to it. Here byx is equal to tan theta. That is tan theta, which is slope byx, is equal to on upon mn. Thus byx is equal to y minus y bar upon x minus x bar. Hence y minus y bar is equal to byx into x minus x bar. Solving the bracket, we get y minus y bar is equal to byx into x minus byx into x bar. Further solving the equation, we get y bar is equal to y minus byx into x plus byx into x bar, which reduces to y bar is equal to a plus byx into x bar, as we know that a is equal to y minus byx into x from the given equation of line. Thus, a is equal to byx into x bar minus y bar. Hence, we can get the intercept of the line using the given formula. Now, let's discuss fitting of the regression lines. A regression equation which represents a straight line is of the following form, that is, y caret is equal to alpha plus beta yx into x. Here, y is the dependent variable and x is the independent variable. Beta yx is population regression coefficient of y on x, and intercept alpha is equal to y bar minus beta yx into x bar. In case of sample data, the estimates of beta yx, that is byx, and the estimates of alpha as a are obtained and placed in the equation That is, A is equal to y bar minus byx into x bar, which we have derived in the previous topic. In a similar fashion, the regression equation of the straight line, where x is considered as dependent variable and y as the independent variable, the form of the equation would be x caret is equal to alpha dash plus beta xy into y. The estimates of beta xy is bxy and alpha dash is a dash is equal to x bar minus bxy into y bar. It can also be derived in the similar fashion. Now let's discuss regression coefficient. Regression coefficient can be defined as the average increase or decrease in the dependent variable for a unit change in the independent variable, or it is the average rate of change in dependent variable with a unit change in independent variable. It is represented by beta yx and beta xy for the population regression coefficient. In practice, they are estimated with the help of the sample from the bivariate population under consideration, and these estimates are generally represented as byx and bxy respectively, which can be notationally written as byx is equal to summation small xy upon summation small x square is equal to covariance xy divided by variance x. And bxy is equal to summation small xy upon summation small y square, which is equal to covariance xy upon variance y. Now let's discuss test of significance of regression coefficient in stepwise manner. The first step is comparison of sample B with population value. Thus, the null hypothesis will be beta yx is equal to 0 and alternative hypothesis will be beta yx is not equal to 0. The second step is fix the level of significance, which is usually fixed at 5% or 1% level of significance. Step 3 is to calculate regression coefficient using its usual formula. Step 4 is to calculate student t and standard error of byx. Using the formula t is equal to modulus byx minus beta yx divided by standard error of byx, where standard error of byx is equal to root of summation small y square minus summation xy square upon summation x square divided by n minus 2 into summation x square, where summation small xy, summation small x square and summation small y square can be calculated using the given formula. The final step, that is step 5, is conclusion. If calculated t is less than table t at 5% level of significance and n minus 2 degrees of freedom, then h0 is accepted. Acceptance of h0 indicates that there is no significant regression between two variables in the population. Whereas if calculated t is greater than or equal to table t at 5% level of significance and n minus 2 degrees of freedom, then h0 is rejected. Rejection of h0 means there is significant regression between two variables in the population. Now let's discuss the properties of regression coefficient. The first property is that the range of regression coefficient is minus infinity to plus infinity. Second property is the fundamental property, that is the correlation coefficient between two variables x and y is the geometric mean of the two regression coefficients beta yx and beta xy, or byx and bxy, which can be notationally written as rho is equal to in the root beta yx into beta xy, and for sample r is equal to in the root byx into bxy. The third property is signature property, which tells that the signs of regression coefficients and correlation coefficients are same. That is, beta yx is greater than 0 then rho is greater than 0, or beta xy greater than 0 then rho greater than 0. Similarly, if beta yx less than 0, then rho is less than 0, or beta xy less than 0, then rho is less than 0. The fourth property is the mean property. It tells that the arithmetic mean of the two regression coefficients beta yx and beta xy is greater than or equal to the correlation coefficients between the variables x and y, which can be written as 1 by 2 beta yx plus beta xy greater than equal to rho. The fifth property is magnitude property, which tells that if one of the regression coefficient is in a simple linear regression is greater than unity, the other is less than unity. That is, if beta yx is greater than 1, then beta xy is less than 1. Or if beta xy is greater than 1, then beta yx is less than 1. The sixth property is independence property. That is, if the variables x and y are independent, the regression coefficients are 0, which is rho is equal to 0. Thus, sigma xy is equal to sigma yx is equal to 0. And hence, beta xy is equal to beta yx is equal to 0. Further, regression coefficient is independent of origin but not scale. Regression coefficient has unit. Regression coefficient has one-way relationship. Now, let's see the uses of regression. Regression can be used to predict the value of y for a given value of x with the help of regression equation. And second use is to know the rate of change in y for a unit change in x with the help of regression coefficient. The relations among small r, byx, bxy, sx and sy is as given. That is, r is equal to in the root byx into bxy, and byx is equal to r into sy upon sx, and bxy is equal to r into sx upon sy. Now let's see the differences between correlation and regression. Correlation deals with mutual association. Regression deals with cause and effect relationship. It is a two-way relationship. It is a one-way relationship. Correlation coefficient is unit-free. Regression coefficient is in the units of dependent variable. Correlation coefficient lies between -1 to +1. Regression coefficient lies between -infinity to +infinity. For a given value of one variable, other variable cannot be predicted. For a given value of independent variable, the value of the dependent variable can be predicted. Correlation coefficient is independent of both origin and scale, whereas regression coefficient is independent of origin but not scale. Thank you for joining me on this journey through our 18th unit regression. If you found this unit helpful, don't forget to like, share and subscribe to Statistics for more insights and clarity on statistics. Your support helps us continue creating content that makes complex topics simple and accessible. Follow us on Instagram and LinkedIn.